One of the most useful distributions is the normal distribution. And in this video, we're going to specifically talk about the one that is called the standard normal curve. The standard normal curve is a bell-shaped curve with a mean equal to 0, and the standard deviation is equal to 1. So if we were to draw a picture, we would have the mean of 0 on our z-scale here. Z is 0. And the curve starts low, comes up high, and comes back down. You'll recognize this from when we talked about the empirical rule. And as we look at this picture, z-values below the mean are negative, and z-values above the mean are positive. And the number 0 right in the middle, that mean, cuts this in half. So if this is a probability distribution, we know the entire area is 1. So if we cut it in half, we find out the area of each side is 0.5, just cut right in half. And there are lots of ways to find the areas of individual parts of this distribution. Remember, area is the same as probability. So to find probabilities off the standard normal curve, one common way is to use technology. And we're going to use Excel, which can find the area to the left of a z-value. The formula we're going to use on Excel is equals, and we'll type in norm for normal, N-O-R-M, dot S for standard, dot dist for normal standard distribution. And then we will type in the z-value, comma, and then we'll use the word true. And we'll always use true for the last argument. So norm.s.dist, open a parentheses, z, true, close the parentheses. Let's take a look at how we can use Excel then to find areas of different parts of the normal distribution. For each of these problems, before we go right to finding the area, it is very helpful to draw a picture to model what we're taking a look for. So this first one's asking for the area to the left of negative 1.21. So if I were to draw a picture of the normal curve with 0 in the middle, we want the area to the left of negative 1.21. Well, because it's negative, I know it's to the left, negative 1.21. We want the area to the left. I'll shade that area to the left. Now, if you remember, the command in Excel always gives the area to the left of the z-value, which is exactly what we're looking for here. So for this first example, I can just type in equals norm.s.dist for standard normal distribution, open a parentheses, type in the z-value of negative 1.21, comma, and then we'll always type in true and close the parentheses. When I hit enter, it's going to give me the area to the left of negative 1.21 on the standard normal curve is 0.1131. In other words, the probability that I'm to the left of negative 1.21 is 0.1131. For the second example, though, we want the area to the right. And let's look at how that is similar and different. The mean of 0 is right in the middle. We're interested in the number 0.42, which is positive, so it's over here to the right. And the question is asking for the area to the right of that value. So that's over here on the right side. The problem with looking for an area to the right side is Excel does not have a way to directly find the area to the right of it. So instead, what we can do is we're going to find the area to the left. And we can do 1 minus the area on the left. And that will equal the area on the right. Since we want the opposite area, we're going to do 1 minus. We're going to take away all that red area to leave us with the blue area. Norm.s.dist, open a parentheses. The z value we have is 0.42. And we always type in true and close the parentheses. And when I hit enter, that will give me the area to the right, which is 0.3372. So the probability of being to the right of a z value of 0.42 is 0.3372. We can use a similar logic to find the area between two regions. Let's say we want to be between negative 2.43 and negative 0.95. So negative 2.43 is off here to the left. And negative 0.95 is a little bit to the left. And we want the area between it. Well, Excel doesn't really find area between directly, so we're going to have to kind of do a similar thing that we did when we wanted the area to the right. If we first found the area for 0.95, that's going to give me all of the area to the left. And I don't want this little bit that's to the left of negative 0.243. So we can subtract off that area that we don't want in our formula. In other words, we can start with the bigger chunk, the one to the right, equals norm.s.distribution. The z value is negative 0.95, and we will say true. That would give me all the area to the left of negative 0.95, but we don't want that little bit, that little tail past 2.43. So we're going to subtract off the part we don't want. We don't want norm.s.distribution, everything past negative 2.43, comma, true. And by subtracting those two values, it'll leave me with the area in the middle being 0.1635. The probability we fall between negative 2.43 and negative 0.95 is 0.1635. So it really helps to draw a picture for every one of these problems to make sure what we type in Excel gives us the area we actually care about and want to know about. In this last example, we want the area outside of negative 0.52, that's to the left here, and 1.43. It's positive, so it's to the right. And we want the area outside those two tails. Well, this one we might need to get a little bit more creative on. If I just wanted the area to the right of 1.43, we could type in 1 minus and then cut off everything to the left of 1.3. But that cuts off the 0.52 we want, but that's also a left tail. So we're going to add back on the left tail after we cut off everything to the left. So that breaks it down into multiple steps here. First thing we're going to do is 1 minus the norm.standard.distribution, 1.43, comma, true. Doing 1 minus gives us the area in the right tail. But that also cut off the left tail that we also want. So we're going to have to add that left tail back in, norm.standard.distribution. We're adding back in the negative 0.52 area, true. When I do that, we end up with the area outside of those 2 points being 0.3779. The probability we're outside of those two numbers is 0.3779.